Hello, everyone, and welcome to the Scaling Ethereum 2024 Filecoin Workshop, Customizing Your Own L2 Subnet with IPC. And joining us today is Longfei Wang, who will be taking us through this session. And with that, I'll pass it over to Longfei to get the session started.
Thank you for the intro. I was just trying to switch, looking for the mute button. Sorry for a little bit late, but super glad to be here and talking about one of those new technologies that Filecoin is working on, which we call IPC, Interplanetary Consensus. And so a little bit introduced about myself. I'm a developer advocate working with Filecoin about 3 years. So I've been working with Filecoin trying to educate developers how to build on Filecoin, how to onboard your data, either it's a Web2 data or Web3 application data on Filecoin. And after that, we start working on this smart contract layer on top of Filecoin, which is FEM. And then now we're working on the scalability solution, which is interplanetary consensus. And it's not just the scalability solution on Filecoin, but we're aiming to build this solution, this IPC framework, to be able to anchor to any of those L1 network, but starting on Filecoin or also starting on the storage primitive on Filecoin. So, and before we jump into it, I would talk about a little bit about how everything gets started, right? Like how we start working on Filecoin, FEM, and now IPC. I think if you guys are following Filecoin or following what Protocol Lab is doing, and you probably pretty familiar with the Filecoin master plan. But if you're not, I'm going to talk through this a little bit. So basically, Filecoin is the decentralized storage network, and we're building a reliable, verifiable storage network for the Web3 as well as for the Web2. And then everything started back from 2014, and when Protocol Labs start working on the IPFS, which is the peer-to-peer file sharing network. And then starting from 2017, we want to build the reliable network, not just the peer-to-peer file sharing system, but a more reliable, more verifiable, plus the incentive mechanism on top of that. And then the Protocol Labs start building Filecoin, and which is the decentralized storage network. So the goal for the Filecoin is providing the decentralized, the reliable storage network for any of the Web3 application, as well as Web2 application. And then we're planning to achieve this Filecoin goal by doing 3 steps. So first, after the mainnet launch, our focus is building the network, making sure the network has enough storage capacity to be able to support the growth of Web3 application, as well as touching the Web2, be able to providing the decentralized storage for any of the needs coming from Web2. And so for the past 3 years, we've been focusing on that on the one side of our road. And we're on board around, I think is over 10 gigabit of a storage on Filecoin, which is huge. I think look at the data back for the Google or Microsoft, it takes them decades, maybe a little bit around decades to build this size of a network, storage network. And then took Filecoin 3 years, 2 years to build that. And after we have this storage capacity, and we want to make sure all those storage, all those decentralized storage are being used to store the most valuable storage, the humanity data. So, and then the second step is we're working with Web2 world, or working to Web3 application to onboard the valuable data on Filecoin so we can store it. And there are a couple of examples that we're working. For example, we have worked with the New York City public data. We store and back up the data on Filecoin. And we also work with Internet Archive to store the archive data from Internet on Filecoin. And in terms of Web3, I think 1 month ago, Solana released a news that Solana has starting backing up the blockchain data on Filecoin. So this is all the steps that we've been making to onboard data on the Filecoin to take the advantage and use the storage network on board on a Filecoin. And what's come after that is once we have the storage capacity and we have the data stored on Filecoin, how we can make those data valuable, right? And then how we can bring the computation around the data, how to use this data to train your AI model, to train your machine learning model, to make it more valuable. And that's what we're doing right now on the step 3. And then what's involved in that step 3? First is how we are providing the ability for the applications to be able to compute over the storage, the data stored on Filecoin, right? That involves to bringing in the smart contract layer on Filecoin. Without that, some of the operations, some of the computations, and the verifiability has to be achieved off chain. So in order to make all this process on chain, and we work on the FVM, the Filecoin virtual machine, and then bring in the smart contract, the programmability on Filecoin. And with the help of FVM, developers' applications can store data on Filecoin at the same time, can compute over the states, over the metadata of the data stored on Filecoin to build application around the data they put on Filecoin. And once we have that ability on Filecoin, we start realizing that on the layer 1 of Filecoin, everything become a little bit slower because the most valuable, most important job on Filecoin is store data, generating the proof for storage provider, and generating the proof using ZK for the client to be able to verify whether or not their data are stored on Filecoin network. And those operations are very consuming on the time, consuming on the block space. So, and then now we have a smart contract layer on top of Filecoin, which make things even slower. And at that point, scalability is becoming super important on Filecoin, right? We want to providing the storage capacity on Filecoin, plus computation, and also with other possibility around computation, for example, dynamic NFT, and then data insurance and data DAO application. All this running on Filecoin make it difficult, considering the block time, considering the TPS on Filecoin. So and then it makes another solution, scalability solution on Filecoin, super important. And that's what we bring in IPC, the interplanetary consensus. And the end goal is hopefully with this scalability solution, and you can resolve the demands from the Web 2 or from Web 3, as well as the growth of the network, right? Like once the more and more application onboarded on Filecoin, and more and more scenarios built on Filecoin, and that network be able to handle all the transaction, to be able to process different application with the demand of the need, the speed of demands, or the size of demand. So that's why IPC come in the picture. I'm just going to pause here and look at if there are any questions. Okay. Yeah, I saw a few messages. I thought it would be a question, but if it's not, so I'm gonna keep going. And if there's any questions, you guys can put it in the chat, and I will stop occasionally to answer them. If I forgot, I will go through the questions by the end of the workshop. All right, so I'm gonna keep going. So and then let's talk about what is IPC, right? IPC we call it interplanetary consensus. It's going to provide the scalability solutions on Filecoin, and we are hoping to achieve the planetary level performance for Web3 as well as Web2, right? If you use IPC, and you'll be able to getting the better performance on putting on your project on any of layer 1. And it's also helping to provide that to the Web2 limit, to reach to the Web2 limit as well. As we know, like all this on e-commerce application on the current Web2, and then the performance is super good, and we're hoping to build the next generation app on top of IPC, be able to achieve that and be able to providing those kind of performance on the Web3. But at the same time, we want to making sure the IPC stack providing the frictionless developer experience to be able to make a team to be able to bring up this the layer 2 or layer 3 network with a simple click of the process, and be able to configure the network based on how the network they want it to be. And so essentially it's going to be infinity scalable solution. And then it's a hierarchy consensus. You'll be able to spring up your layer 2 or layer 3 network on top of a root net. And also at the same time, be able to provide the seamless communication through blockchain. We're not going to bring on the scalability solution to build an isolate blockchain, but in a blockchain, a hierarchy way anchored to any of the root network. A root network could be Filecoin, Ethereum or other blockchain. But at the same time, all this parallel blockchain be able to seamlessly communicate with each other and sending a smart contract invocation, be able to send the tokens among them. And then also the IPC framework is modular. So because of the design of the FVM, which is designed as Watson based, could be able to support multiple language. And then the most importantly, it's EVM compatible. So you'll be able to provide the better interoperability between different blockchain. At the same time, because it's modular, so you'll be able to configure and then pick the consensus mechanism you want and what kind of token design you want and the gas model you want. And then which come to the next important part is IPC is super easy to customize based on the project need. So you can set up how you want to manage your token, how you want to pay your gas, and what's the membership rule of this blockchain. Is it going to be consortium blockchain? Is it going to be public or private? Or so all this can be configurable on the Filecoin. And then this is also, on IPC, and this is also one of the main topic I'm going to talk through today is how to customize and your network using an IPC. So essentially, I've been talking about IPC, but how it's being designed, right? Like IPC is a framework, a stack that you can use to bring up a subnet. So this subnet can anchor to any of the L1. First, obviously, we're gonna anchor to Filecoin, and then, but eventually in the future, we're gonna make it be able to anchor your L2 or L3 solutions on any of the L1 solution, like Ethereum, Bitcoin, hopefully in the future. So, and with the subnet, you'll be able to build your scalability solution horizontally or vertically. For example, if you want to build a gaming subnet, and if you want to build a database subnet, if we want to build a data storage, onboarding, aggregator, all this going to be horizontally scaled. At the same time, you can vertically scale application. If you want to build a game project on your network, and then providing a game for different region, or maybe you want to build a storage application to provide the storage capacity based on the policy for different regions. So you have that vertical scale specific of a different region. And then at the same time, as I mentioned earlier, all this will be able to communicate that in between different subnet. And at the same time, the IPC subnet anchor to and rootnet. A rootnet, we take a Filecoin as example, right? Because it's an anchor to rootnet, so it will take the security feature and then from the Filecoin, based on the communication way of what we call it top-down messages and bottom-up messaging. So basically, top-down messaging is checking the finality on Filecoin and making sure that all the transactions, all the message flow through subnet are secure and then safe. And at the same, also checking the finality, right? We have to execute the transaction, execute smart contract once the transaction are finalized on the rootnet, and be able to verify the signatures, are they coming from the validators. And the other way around is how to submit the state from a subnet back to a rootnet, and all this are achieved by the bottom up checkpoint. So periodically, subnet has to checkpoint what's happening in that subnet back to the rootnet for the verification and for the safety of the network as well. And eventually, the IPC subnet can take that feature and then providing the security and anchor and use the security from the rootnet. And then at the same time, also the liquidity or token value are added to the subnet. So it's also one layer of the security on the subnet. For example, like if we use the token on the L1 as a proof of stake to join any of the subnet, so that's also a layer of the security. And then eventually, IPC be able to providing those features on Filecoin network, providing the data availability and providing the cross-network community, and then building a different layer of a subnet, or maybe a L2, L3, or L4 subnet on Filecoin. And one of the main topic I want to focus today is IPC is hyper customizable. So you can customize IPC based on your need. So for example, the easier way, that you be able to customize the consensus. You want to use a BF team consensus, or you want to use a proof of stake consensus, as well as the easy as block time. You want to have 1 second block time, you have 5 second block time. And then once to the more complicated process, if do you want to have your own smart contract runtime environment? Because of the design of the FVM, Watson-based virtual machine, and we'll be able to bring more and more VM on top of IPC. The Watson VM, the Aqua VM, or maybe Solana VM on Filecoin. And that's something that you can also customize in the future. And besides of that, we're not enforcing all those L2 to use the token from L1 as their native token. For example, we're not enforcing the L2 built on Filecoin to use Filecoin as a native token. But other than that, they can also choose to create their own token on L1 or on Ethereum, and then be able to bridge those tokens on the Filecoin L1, and then use that token as the native token on your subnet as well. And then all those are super easy to customize on Filecoin on the IPC stack, and some of those can be achieved by using 2 features on the IPC. One is building actor, and then second one is system call. So if you are an engineer, and you're probably very familiar with these 2 concepts, right? So in the Filecoin ecosystem, in the Filecoin stack, we call a smart contract as the actor. It's all become the design because of the design of the Watson of the roster. We like to call it actor, but essentially it's just one of the contract running on Filecoin, because it's a built-in. So those contract will natively deployed once you deploy your subnet. And for example, currently on the IPC, we have 2 building actor. One is the IPC gateway actor, and then one is the IPC subnet actor. They are both are building actor, and then will be deployed when you bring up your subnet. And IPC gateway actor is basically responsible for the communication, what I mentioned earlier, the top-down finality check and the bottom-up checkpointing are going through the gateway, as well as all the communications between subnet. And then the second is IPC subnet. Obviously, this IPC subnet actor is responsible for creating a subnet, joining a subnet, and all the staking and the penalty process is going to be handled on the IPC subnet. Besides of that, because FVM is the native virtual machine and the runtime environment for IPC, and then also FVM bring in some of the building actor as well, like how to process the Ethereum accounts, make it EVM compatible, and how to distribute reward, and how to do the initialization. All this are the FVM building actor. And then, so because that's the essential features when you deploy your IPC subnet, so you can also customize that feature. For example, one of our partners, Tableland, they are building a decentralized database. So they're also considering to customize the database feature as the initial function for that subnet. So they will create the custom actor to take care of the table creation, and then the table column data manipulations as a custom actor. And then those features will become native for that specific subnet they're building as a database, a decentralized database. And apart from the building actor, building smart contract / building smart contract, and then another way is customize the feature through the FVM blockable system call. So for all the blockchain network, or even for the Web2 application, system call still sounds familiar, right? Those are the system functions, the system APIs that you can use to interact with the parameters, the data from the system level. On the blockchain, you can think about providing the APIs, the calls that you can interact with the chain state. You can interact with the chain specific features. So on the Filecoin FVM, they will have provide a lot of the system calls, a system to create and resolve the smart contract and to on the Filecoin. And then the system around the cryptographic, how to verify a signature, how to generate a ZK proof to verify that this data is stored on Filecoin, and how to generate the data randomness on Filecoin. All this are implemented through the system call. And on this level, so you also, as if you're interested to build your own subnet, but there are features that to interact with the network layer, or network parameter is not available, and you can also consider to customize those features through system call. And one of the example that our partner Fluence is doing. So Fluence is the decentralized computation layer 2 on Filecoin. And so what they are doing is they are interested to use another random generate feature, which is not DRAM. So they are interested to bring that feature using that randomness generation. So they customize the system call to generate the randomness using the random X, if I remember right. So they custom that feature as a customized system call, and then that's being built and implemented in their subnet. So on their subnet, they could be able to call that system call to generate the randomness value. But here I need to mention something super important, because system call is interact with the chain state. So all the functions that you implement, you customize with system call has to be deterministic, right? You cannot implement a system call which will break the network, which will break the decentralized network, because the output, the execution is not deterministic. For example, generate a randomness value and then calculate as 1 + 1. All those are deterministic. And then this is something that's super important I need to mention here. But essentially, if you're looking for customize your system call, and you can do it. And then how you be able to do it? And this is the brief picture that I draw to show you guys how you're supposed to do it. So basically, it's on the FVM level. We designed the system call as the pluggable. So on the top half is how the Filecoin FVM syscall is designed. So basically, the first step is if you are writing a system call, you have to handle that system call. What I mean handle is by linking your system call, the name of your system call, to an execution of some code, right? So this is linking your execution to a system call. And at the same time, there's like a basic default kernel designed in the FVM, and you have to implement, extend and implement, which is how to basically, for example, how to calculate the gas and how to charge your gas based on the price list. And this is a default function coming from the default kernel. And if you're extending the Filecoin kernel, you have to extend and implement this feature as how to verify a post and how to verify a consensus for. This is for the rootnet on the Filecoin. And eventually, all this system will has to be extended and implemented. But this is how FVM syscall is designed. And to customize your own system call, all you need to do is you can declare a customized kernel. And in a customized kernel, you have your customized function. So whatever function you want to customize in there. And then you implement all this function here with how this procedure, how this customer's system will be implemented. At the same time, you want to implement the link system call to link your system call to the execution, as well as implements the default kernel function. So once you have that custom system call implemented, you can inject it into the IPC code. So when you run an IPC, all the system call will be ready and to be ready to use in the system, as well as through the smart contract, which is /actor. So all this are the process you need to do. And I'm not going to show you guys how to do it because it would be complicated to cover in half-hour workshop. But if you're interested, and you can go down on the docs IPC.space, and we have a tutorial going through how to customize your subnet through the system call and actor. And then once you have that customization finished, you can learn how to deploy a subnet from this tutorial as well. Yeah, sorry, the internet is a little bit bad. So basically, this tutorial of advanced subnet customize is walking through the process of writing your customized function and then linking to a system call, implementing some of the default behaviors from FVM. So in order to inject that into IPC, at the same time not losing any of the default function coming from the FVM. I will let that load a little bit and let's look through the question.
Yeah, there was a question from Alfred. He's got a few questions actually.
Okay.
If you want me to read them, I can. Unless you found them.
Yeah, I found them.
Okay.
Thank you. I'll look through them. So thank you for Alfred. The first question is, what are the performance improvement seen with the IPC approach, or expected any reference or benchmark? So for this question, thank you for asking. But currently, the IPC, our engineer has been focused on bringing those customized features on IPC and then improving the developer experience. So in terms of the benchmark data that we don't have like available, but some of our partners have been building on IPC, so they've been testing it. So on the Filecoin, the block time is 30 seconds, and then the performance, you can imagine it won't be too fast. For non-IPC, you can set up your block time as 1 second, 3 seconds, and so the performance improve is like dramatic. But we don't have the benchmark data ready, so but that's something that we're looking for provide once we have the customization, everything is more stable. So the second is what about quantity limit or maybe more cost per transaction? So the default settings on the Filecoin on the IPC is using the same gas limit, block limit on Filecoin. So that's going to be the same as execution. For example, invoking a smart contract will be the same as the Filecoin. The only difference is the sorry, I lost my English. But the difference is based on the network, right? On Filecoin, there are tons of networks, so you have to pay more priority fee to execute it. But on IPC, it's lower, and that's what default setting is. But at the same time, you can also configure that on the IPC and then use a different gas. And then the third one is the consensus customization. So we have tried to use two different consensus. So when we first built IPC, we built by extending the Filecoin lattice, and that's using using the Filecoin consensus. But we also change it up later to use the commit BFT, which is the core of the Tendermint. So it's using the kind of a BFT consensus to process that. And in the future, we are looking forward to extending more consensus as well. Do we have more questions? I saw a lot of messages going around.
Yeah, there's a couple of more from Imran. They say, as we're developing a chat application similar to Discord, we're exploring different options for managing data within our state channels. I'm particularly interested in understanding if Filecoin could be a suitable solution for storing the data exchange within these channels. Given Filecoin's decentralized storage capabilities, it seems like it could be a promising option. However, I'm curious to hear your thoughts and insights on whether Filecoin integration would be feasible and beneficial for our project.
I think Filecoin standalone, it will providing the storage solutions for your application, right? But if you're building something similar to Discord and you want to be able to access your data whenever you want, as fast as you want, but if purely on Filecoin, it's not that fast because the generation proof and everything, but you can consider to bring those features on the IPC, right? Like on top of IPC, you can have your network to be able to handle the fast data store and the retrieve, and only process the storage process on Filecoin rootnet, right? So it's essentially it's like a layer two on top of Filecoin for your application. You only store data, you only anchor your data to the Filecoin uh, just for the storage, right? Like on the Filecoin, all the data are prepared and then stored in a matter of 32 gigabit or 64 gigabit, right? You want to have all this data like collect all this data and then be able to pack into this size of the sector. So I think it's feasible. It's going to be something that you can build using IPC plus Filecoin. But if you want to use Filecoin standalone to build that, you will find some limitations in terms of performance and in terms of the access to the data, because Filecoin is good to use as a cold storage, as backing up your data, because the process of storing and then retrieving is kind of a slow if you only use Filecoin. But if you use something else as IPC or like a Web3 storage and Lighthouse storage, providing the hot storage layer on top of Filecoin, and that would be easier. But also using those hot storage solution cannot will not solve your scalability or performance issue, and that will be processed and handled by the IPC. So I think that would be a great example. Sorry about my internet. So I was about to walk through the process of how to customize your system call, but we are running over a little bit of time. So if you're interested, you can go here, and that's all the process to teach you, to walk you through how to customize a system call, and all the steps are here. So if you're interested, feel free to go try it, and as well as trying the deploy subnet tutorial, because that's essentially what you need to do once you customize your system call and inject into the IPC stack. All right, sorry, running over a little bit.
But that's fine. And we do have, I think, maybe one more question from Alex.
Okay.
Hi, it looks impressive, but how are the issues of intellectual property ownership and privacy handled when the goal is to make all this data available for training AI?
Uh, so this is a good question. This is a question I've been asked for Filecoin a lot, because once the AI come into the picture, and then the privacy are like essential for this data. But for the Filecoin layer, that we don't really handle the ownership and the privacy from the Filecoin layer, because in terms of Filecoin, we only store data, whatever the data that the application sent to us, right? So which means that the privacy and then the ownership of the data has to be processed and handled by the application. So if I'm building an AI and I want to store my data on Filecoin, but not as a public, then my AI application needs to use some of the service, some of the toolings of infrastructure on Filecoin to like encrypt your data, to gate the access of your data. So, and all those are, we also have those toolings on Filecoin. For example, Lighthouse be able to providing the storage plus the privacy as encryption. You can choose to encrypt, you can choose to store a data publicly, or you can choose to store data as encrypted. And then also you can use Lighthouse to gate access, right? You can use sorry, not Lighthouse, Lit protocol. You can use Lit protocol to gate access. And for example, I'm storing my data, my training data on Filecoin, and I only want to give those access to the member of my project, my application, and those access control can be achieved by Lit protocol. But on the Filecoin layer, we don't really handle the ownership of privacy directly, so the project has to handle that by themselves. I hope that answers your question.
Nice, awesome. Well, cheers. Yeah, I think we can probably end it here since we're a little over. But Longfei, thank you again for the great presentation and workshop. And thank you everybody else for answering these great questions as well. As a reminder, hacking begins and it will be announced in a couple hours during the opening ceremony. So don't miss that. And yeah, everybody have a great rest of your Friday and have a good weekend. We'll see you here in a bit soon. Cheers. Thank you.
Thank you. Thank you.